Hello, class 12 science. We are coming to the end of the chapter chemical kinetics, and today we are going to discuss about the Arrhenius equation. Arrhenius equation is the relationship between temperature and rate constant. That means how rate constant is related with the temperature. Arrhenius equation, it tells us about the relation between temperature and the rate constant of reaction, and it is expressed as follows. Capital K equals to A into e to the power minus EA by RT. Now, each symbol has got their own significant meaning. K is a rate constant, capital A is frequency factor, or we call pre-exponential factor. EA is activation energy, R is gas constant expressed in joule per Kelvin per mole, and T is temperature in Kelvin. Okay, so this is the relationship between temperature and rate constant, how temperature is related with rate constant, and this equation we commonly call as Arrhenius equation. The frequency factor A gives the frequency of binary collision of the reacting molecules per second per liter. So there is a frequency factor A, which means that it is the frequency of binary collision of the reacting molecules per second per liter. The two quantities A and EA are collectively called Arrhenius parameter. So when you have got A and EA, they are called as Arrhenius parameter. The factor E to the power E minus E to the power minus EA by RT gives the fraction of molecules having energy equal to or greater than the activation energy, and it is called Boltzmann factor. So this factor is known as Boltzmann factor. Now, once again, this is the Arrhenius equation. Now what we'll do is we'll take the logarithm to both sides. By taking logarithm to both sides with respect to base E, this becomes ln k, and this is ln a into e to the power minus ea by rt. Then we have got the formula of logarithm log a into b, that is log a plus log b. So we have used the same equation over here, so it will become ln a, and this becomes plus ln e to the power minus ea by rt. So if you have got something in the power in the logarithm, it will come in front. So since we have got minus ea by rt, it will come in front, and it becomes ln e. So logarithm with respect to base e, the value will be 1. So finally it becomes as ln k equals to minus ln a minus ea by rt. Okay, now when you convert this ln to logarithm with respect to base 10, we need to multiply with the factor, we can say 2.303. Okay, so when you multiply this factor by 2.303, so the all this numerator will become 2.303. Now when you take this 2.303 to the other side, so the equation will change as log 10k equals to log 10a minus ea by 2.303 by rt. Now for two different reaction, rate constant and temperature will be different. So for K1, this will become T1, other will remain as it is, let it be equation 1. And for rate constant K2, this T will become T2, so let it be equation 2. Now subtracting equation 1 from 2, so subtracting this equation from this one, it becomes log K2 minus log K1 equals to this minus this minus this, log a minus e1 by ea, this is ea, okay, just correct it, ea by 2.303 rt2 minus log a minus ea by 2.30 rt1. Now since we have got log a and log a, one is positive, so this will get cancelled. Now this will become plus, since minus minus plus. Now when you take this common, okay, now before that, log a minus log b, we have got the formula log a by b, so we have written log k2 by k1 equals to, now when you take the common, the common factor is ea minus 2.303 ea by 2.303 r is common. Now when you take out the common, then it becomes 1 minus t1 by 1 minus t1 minus 1 by t2. Okay, this is the Arrhenius factor. Sorry, this is the another expression for the Arrhenius equation on which we will be doing the numerical. in the next class. So once again we came across that the same expression, log 10 k1 log 10a minus e1 by 2.303 rt1. Now from this equation, this equation looks like the straight line equation, y equals to mx plus c, we can say, okay, where this is the m factor, that is slope. So when you plot log k versus 1 by t, okay, 1 by t, then the slope will be like this. This is the straight line and this is the intercept, you can say. Log e will be the intercept and the slope value will become as minus 3e by 2.303. okay. Now today's assignment 7, write the equation that shows relationship between temperature and rate constant of reaction. What is the equation called? Question number 2, derive an expression for Arrhenius equation for two different reactions. Question number 3, draw the graph showing variation of rate constant with temperature. So complete this assignment and send it in my mail.